So this one is question 4 from topic chemical energetics. A student investigated what happened when a dilute nitric acid react with an aqueous solution of two different alkalis, solution N and solution O. So two different alkaline solutions are there, means they might be two different chemical substances, or they might be, as I mentioned, two different alkalis, so there are two different compounds as well. So two experiments were carried out. In first experiment, as a measuring cylinder was used to pour 50 cm cube of solution N into a polystyrene cup. So what student did? Student took a measuring cylinder and he filled it 50 cm cube and he transferred that into a polystyrene cup. Then the initial temperature of the solution, he measured the initial temperature. What is the starting temperature? He measured it by using a thermometer. Then a burette was filled with a nitric acid and 5 cm cube of a nitric acid. So from the burette, he fill the burette with nitric acid like HNO3, and then he add 5 cm cube from the burette. The polystyrene cup and the solution stirred, and a further 5 cm cube of a nitric acid is added to polystyrene. So first 5 cm cube was added, the maximum temperature of a solution was measured, then further 5 cm cube is added, then maximum temperature measured, then further 5 cm cube added, and student add 5 cm cube until it's like till reach maximum volume of total volume of 40. Like first I 5, then add 5 become 10, then add 5 15, 20, 25, 30, 35 and 40. And measure the maximum temperature. After each addition, the solution was stirred and the maximum temperature was measured. Use the thermometer diagram to record the maximum temperature. You can use a screen annotation to complete this. What are the maximum temperatures? Read the thermometer reading and state the maximum temperatures. So first one is 22. Second one is 24. Third one is 26. 28. 30. 31. 30. 29. 28. So these are the temperature readings according to a thermometer. Then experiment 2, experiment 1 was repeated using solution O instead of N. Use the screen annotation to complete this. The first one is 20, then 21, then 22, 23, 24, 25, 25, 24, 23, and 22. So these are the temperature readings according to the thermometer. The volume is added. Then plot the results for the experiment 1 and experiment 2 and draw two smooth line graphs and clearly label your graph. So when they ask to draw a smooth line graph, so we don't need a ruler here. We just have to join the points. We have to draw best fit smooth lines. So I will rewrite the values because I have to plot a graph for experiment. This is the maximum temperature is there, and we have the amount added. So readings were for the experiment 1 and for experiment 2.
So, Mr. The first reading 22 in
22,
experiment 1, and then 24,
24, 26, I think it was.
26,
28 was there, 30, I guess it was there,
Yes,
31 was
30
there,
and 31.
29 and 28. And for the second experiment,
Sir, it's 30, then 31, then another 30.
this one was 22, 24, 26, 28, 30, 31, then 30. Yeah. There's another 30 was there.
And another 30.
30 was there, 29 and 28. And then for this one, we were having 20, 21, 22, 23, because it was, I remember it was a sequence 24, 25, 24, 23, 22. And the amount, like it was in the beginning 0, 5, 10, 15, 20, 25, 30, 35, and 40, like amount which was added. So use the grid, you have to mark the points. So first, I will mark for experiment 1, it is 20, 0, and the values in between are not there. So this will be 5 because two boxes, 1, 2, 3. So this will be 5. Um, this will be 15 because we need them as well. This will be 25. This will be 35. Now we mark the points. Say the first one, 20, 0, like because the first point was at 0, 0 and 22. So here, two boxes equals to 1. So this will be 21, this will be 22. Then 25 and 24. So this will be 24. Then 10 and 26. This will be 26. Then 15 and 28. This 26, 27, 28. This will be 28. And then 30, 20 and 30. So this one is already 28, 29 and 30. This will be 30. Then 31, 25 and 31. And then 30 and 30. And 29, 35 and 29. And then 20, 40 and 28. And we have to draw a smooth line. So we have to join these points. Use thin lines when you're marking a point. Use thin lines. So smooth line graph, you have to join those points to the best fit. This is for, and label them as well, like this is for experiment 1. Then we have to do the same thing for experiment 2. So experiment 2, it started with 20, then 21, then 22, then 23, then 24, then 25, then 24, 23, 24 was this 23, and then 22. So we have to join these points. This is for experiment 2. So these are the two graphs. One is for experiment 1, another one is for experiment 2. As I mentioned, smooth line, so you don't need a ruler or scale here. Don't use ruler to join from one point to another. Use a free hand. The next part, use your graph to estimate the maximum temperature of a solution when 13 cm cube of a nitric acid was added to 50 cm cube of solution N. This was solution because in experiment 1 we were using solution N. In experiment 2 we were using solution O. As it is clearly mentioned here that experiment 1 was repeated using solution O instead of N. So experiment 1 was N and so O is there in the second experiment. So you have to estimate the maximum temperature of a solution when 13 cm cube of nitric acid was added to solution N. So solution N is the first one, 13 cm cube of nitric acid. So you will mark a point like this is 11, 12 and 13. And you have to show clearly on the graph. So you have to draw these lines. So draw a line and work out the temperature. Say this is 26.5. So we'll write as 26.5. So 26.5 degrees is the maximum temperature, or 27 might be there depending on the graph. So you have to show this on your graph. Name a suitable indicator that could be used for experiment. What indicator, like acid, alkali, what indicator we can use?
Phenolphthalein.
Phenolphthalein can be used. Thymol, pathylene can be used. Universal indicator are not suitable for titration because they show a transition of the color.
Range of color change.
Yeah. So range of color change is there. We
We
prefer
will
the
not be
indicator.
able to identify the endpoint.
Yeah, we will not be able to identify endpoint because it's like a series of color and it's hard to distinguish the color transition. Rather than one color changes to another, it's easy to recognize. Then solution N and O were same concentration. In which experiment the so instead of universal indicator, we will use phenolphthalein as an indicator. The next one, solution N and O were the same concentration. In which experiment temperature change is greater and suggest why the temperature change is greater. Which experiment the temperature is greater?
Experiment 1.
So experiment 1, the temperature change is greater. What might be a reason for that? To have a greater temperature change. Any indicator is acceptable. I mentioned phenolphthalein. You can mention methyl orange is acceptable.
Is it reacting with a metal?
No, we have two, as you can see in the beginning of the question, we have two solutions. Two alkaline solutions are there. A student investigate what happened when nitric acid is added to two different alkaline solutions. So if N is giving you a greater temperature than an O, so which solution of alkaline, well, like which alkali is more concentrated or strong? If N is
Solution
giving,
N, because that was used in experiment 2.
so N is more concentrated. What might be a reason why N is giving a greater temperature change than O? So it means, so first thing, in which experiment the temperature change greater? The answer is experiment 1. And what is the reason for that? It means that because N is giving a greater temperature change, so solution N is more concentrated than O. Like there are more particles, more reactions. That's why the temperature changes higher. How would in the question solution, and if they were if they were same concentration, then you will mention like N is a strong alkali, you can mention. If they here it's mentioned is the same concentration, so you can mention solution N is more alkaline or strong alkali, or it is having a higher pH. Because I read it's as you mentioned, it is here it's the same concentration. So as you mentioned, it's the same concentration, so you can mention that N is more alkaline. Why concentration you cannot mention here? Because already they mentioned it, they have the same concentration. How would the result differ if we use 100 cm cube of solution? Like
More temperature change because there will be more reactant particles, more concentration of reactant particles, including successful collision.
so, as a result, the temperature change. If you are using look when you check the question, a student investigate what happened to nitric acid when it react with aqueous solution of two different alkali N and O, and he took 50 cm cube of N and he poured into a polystyrene cup, and then he reacted with an acid. So how would the result differ if 100 cm cube of solution N were used? Like if we use greater amount of N, how the results will differ?
Greater temperature change, greater maximum temperature.
It will be, look, the idea is that when we are saying that we are using 100 cm cube of solution N, what will happen to temperature change? The temperature change will be half. Because we are using a same concentration. We did not change the concentration. As 50 cm cube and 100 cm cube, what is the relation between volume and the temperature change? The volume and temperature change are inverse. If I use because like from the burette, we are adding an acid and we are adding a same amount of acid. So the temperature change will be half. Because if we double the volume, the temperature change of a solution, it will, no, the volume of actually what happened, as you can see here, what we did in the first experiment in a polystyrene cup, we took 50 cm cube of solution N. So we were having 50 cm cube of solution N, and from a burette, what we did, we add nitric acid, and how much nitric acid was added? 40 cm cube of nitric acid was added. Now the second experiment, what we did, we took 100 cm cube of N, and we are adding the same amount of nitric acid, 40 cm cube of nitric acid. So both experiments are releasing the same, because like it means that N is in excess. All of the N won't react. 100 cm cube is more than enough for a reaction to complete. So say this was releasing when 40 cm cube react with 50, because out of 40, 50 will react here. Remaining 50 won't react. So as a result, what will happen if this solution was having a temperature change of maybe 28, then this solution will have a temperature change or a like increase in temperature will be half. So it will be like 14-degree change. Why? Because we just increase one of the reactant, the other reactant we did not change. If I double both of them, so I need a double quantity of hydrochloric acid or nitric acid, not hydrochloric acid. I need a double quantity of nitric acid to produce the same temperature change. Is it clear, this one?
Yes, sir.
It
Clear.
is because the remaining 50 centimeter cube will absorb the heat.
Yeah, that's right. Remaining 50 cm cube is actually not reacting. That is only absorbing energy, and that is the total volume is larger. So the temperature change will become half. So
So
answer.
they increased it by 2 factors, so we will decrease by 2 factors.
In the first experiment, we did 50 cm cube of nitric acid and we add 40 cm cube of, we took 50 cm cube of N and we add 40 cm cube of nitric acid. Now they are saying if we repeat the experiment with 100 cm cube of N and we use the same nitric acid, so that what happened to temperature change? So temperature change will be half, because not all the N will react. Still excess of N is there. Some of the N is unreacted. So how the result differ in experiment 1? If we use 100 cm cube of solution N, the temperature change will be smaller. Yeah, if we want the same temperature, change, then like if we double nitric solution N, then we should double, like this is 40, then this should be 80, like double of 40. If this is double, 50 become 100, so 40 will become 80 for the same temperature change. So answer here, the temperature change will decrease or smaller change in temperature. Suggest why polystyrene cup was used in these experiment, not a copper cup. Why we never use, like we can use copper, but why we don't prefer to use
It
copper?
will just conduct the
Yeah, copper is a
conduct the
conductor,
heat, so
or
we will get an
polystyrene.
accurate value.
Yeah, polystyrene.
Polystyrene cup will insulate it, so we can get more accurate value.
So polystyrene is insulator or copper is a conductor. Any way you can mention. So polystyrene is a good insulator, or you can mention the copper conducts to transfer the heat energy to the surrounding. State one source of error in the experiment and suggest an improvement to reduce this source of error. Like what do you think, for especially for experiments which are related to heat, or you can mention a apparatus or you can mention a technique as well. What might be the error in this experiment? To find the error, like usually you just read the first part of the experiment, you get the error. What might be the error here? Can you identify from this statement, the first statement? Use of a measuring cylinder. Use of lid also, that's right.
We can use
Using a lid is also correct, because we should use a lid to prevent the heat. We are using a polystyrene cup, but we did not mention a lid there. So 50 cm cube, so use a burette. 50 cm cube is there, burette. If it was 25 cm cube, then pipette. So what might be an error? Use of measuring cylinder is an error. Use pipette. Use burette. And another thing you can mention, use of polystyrene cup without a lid. So use a lid on the polystyrene cup, or use lagging or insulation around it.